Hi, today I want to show you how to create a mesh or grid of connected points using a distance-based connection function, and how to create an electric or magnetic-like effect when two such grids are approaching each other. Okay, so let's get started. And yeah, we are just using a simple mesh as basis for our geometry nodes, and then we are deleting the input and putting the a grid as our basic shape with 7-meter size and let's say 40 vertices into the geometry. As we can see, we only see a plane, not the real mesh, so we are converting the mesh to a curve and then back the curve to a mesh, because only meshes can be really handled in the geometry node. If we wanted to give a geometry, a real geometry, so we are giving it a profile, and the circle, if it's 1 meter diameter, it's far too large, and now we can see that's more sufficient if we bring it down to a lower value. And now we are trying to set the position of the vertices of this mesh, so we can move this around using this set position node. But we want to use or to move only the z points individually. So we are connecting a first we have to use a combine XYZ, because we only want to move the Z axis, and we are connecting a random value to this. And so we see, okay, we have some very random Z values here, and we can turn them up and down using this max value here. We are using 0.3 for now as a maximum. And if we are looking from above, we see everything is still strict and parallel. So we are using a noise texture, putting it to the x-axis, and another noise texture, putting it to the y-axis. So maybe that's a little bit too noisy. So let's see if we can turn the scale down to a lower value and have it a little bit wavy, but not too not too noisy. So let's say like this, 1.2 or something like this. And then we have a wavy structure on the x and y axis, and a noise on the z axis, on the z axis. And so that's a good basis. So now we want to instance some points on the vertices of this grid, and for that we take instance on points, and we take a UV sphere as the instance itself. And when we want to see this, we have to add a join geometry node and join these two geometries into the one final geometry. And we see, okay, also again these UV spheres are far too large, so we bring the diameter down and see, okay, let's see, we have to try this out and play a little bit around with these values for the diameter of the tubes, the connections of these points, and the diameter of the points themselves. And now we want to give them a material because we want them to emit light. So we're defining the color of the emission and the emission strength. Let's say 100. And we give this a name, blue light. And then we are adding this material inside, or we have to add this material inside the geometry nodes again. It is not sufficient to define it, but we have to add it inside the so here's some automatic connection done what we don't want, so we have to reconnect everything so that is goes in the right direction, so that way. And now again this, and so we see if we now, let's do that. So if we now apply this material, then we can see, okay, these points are emitting light, obviously. Okay, that looks already good. So let's turn down the environmental light, and now we can see, okay, the lights are a little bit too large. So let's bring down the diameter again to another value. I will give you the final setup at the end of this tutorial, what I then used for the animation you already saw. So we are playing around a little bit with these values to find a reasonable setting for this. And then we can change to the view from above and from the side view, and see if that looks okay. Good. So let's move this out a little bit here, and let's move this out, and let's add now a node for the distance-based connections between the single points, and that is merge by distance. And this merge by distance looks at the distance we are defining here, and the larger the distance, the brighter this mesh will be. So if we set the distance to 0, then the mesh is very dense, and when we set the distance to a larger value, the mesh will be lighter, because fewer points will be connected throughout the setting. Okay, so we see from the side, you can also see this this effect. And now we are adding another set position, because we want to move this mesh according to the scene time. So we will combine an XYZ to this to the mesh, and we will set as an input the scene time frame number with this node, and we will add a map range, because we want to normalize the scene time, which runs from 1 to 250 backwards, because we want to bring this from the maximum to the minimum during the scene to this combine XYZ. And then we see, okay, if we are running the scene time. So if we are running the animation, the mesh is brought down the z-axis during the process. Okay, so since we want to have two of these meshes, we are doubling the whole setup and are adding a math node because we have to multiply the second mesh by -1, the z-axis, because one has to move upwards and the other one has to move downwards. So to see what is happening here, we have of course to join these geometries again, like this. And now we can already see these distance-based approach is also working between two of these meshes. And if we are running the animation, these both meshes are getting closer, and we see the closer they are, the more connections they are building up, like some kind of magnetic effect. Okay, so that is what we want. That is what we want to achieve. And now we can change our view, and let's see how this looks through a camera. The normal lighting we have. Okay, that is a little bit too dark. So let's see what we can do to make it a little bit lighter. Maybe we have to increase the diameter of the sphere again, and also maybe the diameter of the connections between these points. And yeah, okay, that looks a little bit better now. And so we can see, okay, this looks like what we want. So if we see this in an animation through the camera, we see during the time this network is connecting by distance. And if we now define some planes around this scene to have some reflecting effects for the optics, we define this first plane and move it up, and we double it and move it down, and then we give that a material again, same color as all the other stuff, and some very low roughness, so it's reflecting a lot, and give it a name, blue plane, and give both of these planes this material, and we see, okay, maybe it's a little bit too bright in general, so let's move this color a little bit down, and then also adjust the emission strength again of these single light points here. So again, that is a matter of playing around with with all these values, and then we see, okay, finally, if we see, okay, these planes on the starting point are below, so we have to lift them above and below the starting points of our meshes that we have constructed here. And now we see, okay, that seems to be correct now. Yeah. So this in the end is the final setup for the defining part and for the geometry, for the physical geometry part. I've added also a set material node here for the tubes, as you can see. And yeah, in the end, the result of all this is this little animation. So if you like this video, then please like it. And yeah, thanks for watching and see you in the next video.